Good afternoon, everybody, and great to see you. I should manage to hopefully keep you awake for about 20 minutes. I noticed that the yellow and red cards are back. My son is 10 years old, and he's played for the same football team for 5 years. On last Saturday was the first time one of his teammates got given a yellow card. But not only that, a 10-year-old got fined £12 by the referee. So hopefully there'll be no fine if I go over. I'll keep talking until I get told to stop or until I run out of things to say. As Rob said, yeah, a career focused on operations, but interestingly about people. So it's been leadership of people, but now it's about integrating people and technology to de-risk operations. That photo there, it looks high-tech, my favorite photo, because it's got my ship and an aircraft in, but actually it's taken on an iPhone by one of my officers in a RIB, so it's not as high-tech maybe as you would think. And I'll tell a story over the next 20 minutes or so about what are they, maritime autonomous systems, why, how, and a quick look at the future. It is deliberately a reasonably high level. I'm not a deep technical expert, and there are deep technical experts in the audience, and no heckling, James Fanshawe over there. There are people who are much more experienced than me, so I'll try and provoke some questions to ask at the panel, maybe to explore some more areas. So definitions and terminology is important in this area. Autonomy in the context of ships means that the ship can operate without human intervention related to one or more of the functions for full or limited periods of its operational voyage. So it doesn't necessarily mean that there are no people on board. It is related to a specific function. However, autonomous ship system is all physical and human elements that together ensure sustainable operation of an autonomous ship. So humans are on the loop or in the loop, but they are still part of that system. MAS itself, Maritime Autonomous Systems, you often equate with sort of little yellow boats. I don't mean that in a derogatory way, but to do with ocean science and surveying, and generally accepted that they're sub-24 meter. That's not a definition, but that's accepted because it fits nicely into the current regulatory framework we have, which is the Workboat Code sub-24 meters. But it doesn't exclusively mean that. And there are ships out there, as we talked yesterday, some keels being laid down for now on 80 meters autonomous ships. The Royal Navy has just bought a 43-meter optionally or partially crewed vessel, of which they'll test and develop and take people off slowly to work out exactly how to do that. But actually, it's all part of the smart shipping spectrum, and you can see the definition there as the DFT, which is the entirety of the maritime sector, which maritime autonomous ships is part of that entirety. But we have had autonomy at sea for some considerable time, and we have now live autonomous operations, as you heard from Seamus, and I'll touch on the other Fugro operations. But we've had autonomy in some areas for a considerable time. For example, remote engine monitoring at sea. We've had it in aviation for nigh on 50 years. You don't see engineers flying anymore. We've had it in a remote access of emergency or fire suppression systems in engine rooms. And so autonomy has been at sea for some considerable time, and it's increasing. I was excited, but then I had to have a quick word with myself. It's not that exciting. But if you manage to get into a lift in the Hilton Hotel, of which only 1 of 3 are working, you'll see a sign that says remote elevator monitoring. So call this number if you're stuck. So that, I mean, that for goodness, I took a photo and then realized it's not exciting enough to put in a presentation. But it is interesting, isn't it, that autonomy comes into every part of our life, whether you know it or not. And the last bit of definitions, because International Women's Day yesterday, we're still working on some of those definitions, but for the purposes of now, unmanned means there's nobody at all on the craft. It's not indicating gender bias, although there's work in progress to change that. Uncrewed means there's no crew, but there may be passengers or other special people, like engineers or OEMs. So unmanned and uncrewed have 2 specific terms, definitions. So why maritime autonomous systems? It's a journey, not an end in itself. So there has to be a good reason to have autonomy embedded in use case. In the military context, many reasons why: lethality, increase in mass, operational advantage. And actually, one of the most compelling use cases in the military context is take the people out of the minefield. Very dangerous area to be, although divers would tell you otherwise with their big watches and tight T-shirts. But it is a really dangerous place to be. So take the people out of the minefield and make it autonomous. That's clearly a safety of life compelling use case. Interestingly, the Navy have got are moving towards a concept where autonomy is embedded at the heart of everything they do. So as alluded to, autonomy at some scale is part of everything they do in acquisition. So it could be decision support aids at one end, full through to full autonomy at the other end. The commercial reason why, now there are clear commercial benefits to autonomy, but it depends really on the use case. Generally revolving a reduction of some sort of hotel services with second order benefits of maybe increased time between port, reduction of how often you need to resupply, efficiency of hull design, so the percentage of cargo versus the overall hull design goes up, and then you can access maybe smaller ports and decrease the cargo move around the country. But interestingly, if you base the premise on reducing the headcount in your organization, that's fundamentally that's quite flawed, because studies have indicated, and certainly Royal Navy's done a bit of scoping work, is that the autonomy embedded in the heart of everything they do. Funnily enough, the workforce or the shape of the Navy is roughly the same in headcount to a conventional Navy. Now, the skill sets are different, and the way you employ them will be different, but if you're doing it to reduce the size of your workforce, that's a flawed reason. In the terms of moving a container vessel to an uncrewed vessel, actually, although it's a complex and it's a complex equation, it's quantifiable, and you can see a statistic there about how much you would save. But there are second and third order benefits to, commercially, and you can see one of the example of that is in the Peel ports. Actually, you can access areas that maybe were not commercially viable before or not possible before. An example of that is the under-ice autonomous underwater vessel that the National Oceanography Centre have sent up to the ice shelf, and I think it's operating as we speak. Likewise, near continuous depth survey of busy ports, with some of these survey vessels have months of endurance and a battery lifestyle. That was maybe not commercially viable to do on that scale before. There is a linked benefit, which I haven't put a slide up, and I think maybe it's one for discussion or question afterwards. It's a bit of a philosophical discussion on safety. So clearly there is, if you're going to embrace new technology in the maritime, it's got to help make the maritime safer. Surely that's a fundamental point. And if you look at, it depends how you ask the question on Google, but between 75 and 95% of accidents are due to some sort of human error at some point. And that's the same across many sectors, and aviation quote that quite a lot, and it's remained stubbornly stable for nigh on 100 years as the engineering and the failure rate goes down. Actually, human error remains static. But the implication of that narrative that humans are bad and machines are good is much too oversimplistic. And those of us who've been at mariners, who've been at sea, are very used to an inexperienced officer of the watch making a binary sort of algorithmic type decision on a collision regulation, a collision avoidance scenario where you base 1 versus 1. And then the more experienced captain will come up on board of the ship and say, actually, I'm using my experience, that that's not the right decision for all these variety of reasons. Some of that is intuition or hair on the back of the neck, but it's all experiential learning that you use your judgment in order to make a different decision. So how do you codify that? How do you embed that in machine learning? And how do you assure that that's safe is a really, really difficult, complex thing to do. And the converse is also true. If you move the human from a bridge of a ship and put them in a remote ops center, then the survival instinct based on danger perception goes down, because you're not standing on the bridge of a ship at a rough stormy night with a vessel coming towards you. You're actually just watching it through a screen. So your self-survival instinct is different. So the safety argument is a really interesting philosophical one, and happy to explore and take questions on that. The environmental reasons and use cases are much more straightforward and less philosophical debate, you'll be pleased to know. The offshore the Renewable Energy Catapult has done a good study into what the top technologies are for both saving money, increasing environmental benefit, and you can say autonomy is actually a good part of that. And the second order effects of the commercial benefits, reduction in hotel services, particularly combined with clean fuels, clearly have a huge environmental dividend. You've heard a lot more from Seamus about the Fugro work, and CEBOT Group, our parent group, have been working with Fugro for some considerable time. Just a summary there, you heard about the capabilities of the Blue Essence vessel, but the figures are quite stark. 80% of the capability for 5% of the fuel with no people on board. It doesn't mean no people. Clearly, there is a local ops center where the vessel is launched and recovered from, and I witnessed at their local ops center in Rotterdam, and then a remote ops center in Aberdeen. So there's a launch recovery of the vessel and operate it by day in the local ops centre in Rotterdam, and then overnight monitoring it in Aberdeen. So there are people, but the environmental benefits, 80% of capability, 5% of fuel, is quite an incredible statistic. Now, in the early days, and in some areas, there's still a requirement for a support vessel, which slightly nullifies or reduces the benefit both commercially and environmentally. But as the skill sets increase, as the regulatory framework and insurance framework gets built, and as the trust and confidence increases, then that requirement for the support vessel will reduce. So I'm going to skim across some of the challenges, and interestingly, the challenges reflect a lot of the challenges that were said yesterday in in embracing the clean fuels in support craft for the offshore renewable sector. The first one, I think, is the hype. Now, we understand that sort of autonomy could be all things to all people or different things to some people, but generally autonomy, and particularly AI, machine learning, gets bandied around as a solution for all problems. At the macro level, the hype curve, you can see autonomous vehicles. Well, the first design of autonomous vehicles came out in 1939. I think it was doing a bit of cursory research. And over the last 20 years, we've heard so much from all different companies who've thrown themselves into the sector, Amazon, Google, Uber, and then a load of companies got out of that sector because they've been sued or it's too expensive. Uber left in 2020, and actually Tesla is still in there. But you can see the autonomous vehicles macro level, we're starting to come out of the sort of trough of disillusionment into the slope of enlightenment. So the autonomous vessels, I think, probably lags that a little bit as the micro level, but it's somewhere, and you'll have a personal view of whether we're over the peak of inflated expectations and maybe starting to come out towards understanding what it really means and what is really the use case for autonomy. And the same with AI. I mean, I'm not a deep specialist in AI or machine learning, but you hear those terms bandied around all the time. But actually, it's more, for our company value, CEbot group values, it's more about IA, intelligent automation, rather than robots are good and they're going to solve the world, and it's AI. So that you can see the IMO definitions of autonomy. They're all basically decision support aids, whether it's autonomy level 1, which it just assists, or whether autonomy level 4, and it does everything. It's about decision support, intelligent automation, using it in the right place for the right reason and the right gain. So inevitably, technology leads the supporting infrastructure and the regulatory framework, but there are still issues in the technology area to overcome. You'll be surprised to know, as an aviator, I'm actually fascinated by collision regulation and compliance. It's a really interesting area, and I touched on some of that before. There is work underway. The military regulator is working with BMT Rembrandt software in the synthetic environment to understand how to assure collision regulation compliance. And I remain skeptical, and I've heard many times from different manufacturers that their software is 100% collision regulation compliance. Well, great, it may be, but it has to be tested and assured by the regulator and then certified as such before you, in my opinion, before you can make that claim, because it is exceedingly complex to operate in that space, and ensuring that the machine learning learns for every scenario and then makes the right reason for the right decision for the right reason is very difficult to understand how to assure that. You might make the right decision for the wrong reason, and that's almost as bad, in my opinion, as the other way around, because you don't know why the decision's been made and what it might do in the future. So really interesting area, and there's lots of work ongoing. Equally, some of those challenges aren't necessarily don't just reflect autonomy or don't just reflect the maritime. In fact, some of those communications is a perennial problem in the maritime, and bandwidth and also latency, but actually it's acute in the autonomous area. But there are lots of experience and lots of people who are working in that area. So CEbotiX, our group, is working with a satellite applications catapult to understand how they approach some of their communications resilience and cyber, and we'll hear a bit more from the next speaker about some of those problems. So that the information is out there, and it's really important we conduct that cross-sector, pan-domain learning. Equally, at the national level, the Knowledge Transfer Network, KTN, and Innovate UK are doing a scoping study on what a UK robotics proving facilities, or test and development, looks like. For me, it's really important to understand how the UK Maritime robotics proving facility may fit into that and what that looks like, and where the coherence is, where there's where we can maximize innovation but not stifle it due to overly controlling at the national level. So that plays into the sort of discipline level approach. For example, the University of York have got an Institute of Safe Autonomy to assure AI and machine learning. Actually, that's irrespective of your particular domain, and you can work in the maritime, the automotive, and the nuclear, wherever it might be. But actually, that discipline level coherence is really important from a UK point of view. And again, I'm not going to deep dive into the training, but really, really important and actually underpins the step towards the future, the next generation maritime. And I know there's a session on it this afternoon. But if you look at it, just to put it into context, if you look at that top line, then if you're a crewed vessel, you've got really well established over 100 years of international regulation. You've got teaching institutions, you've got experienced instructors, and you've got the infrastructure to support you. But conversely, if you look at the uncrewed vessel area, the regulations don't yet exist in a formal context. We don't have people with experience in teaching institutions who can then pass on that knowledge, which is where CEbotiX comes into it. In the regulation side, there's an international working group called Mass People, which is aiming to put together a set of standards to recommend to the IMO how you may impose some standards to accredit against. And lastly, assurance and regulation, a really big topic, and we had the privilege to hear from Brian Johnson yesterday about the clean fuels regulation, and actually we have all the sort of similar challenges. So IMO are doing work, they've done their scoping exercise, but the optimists would say that they were going to put some regulation in place by 2028, and I think the cynics would probably say that's slipped to 2032. The MCA are doing some really good work on looking at what a review of the primary legislation might look like, because there's a real opportunity to set us up for success in the future, but clearly that's a big bit of work, and it'll take a few years to work through if we then go back to primary legislation. In order to fill the gap, there are a variety of re-editions of certain areas, like the Workboat Code is coming out for a new edition this spring that should get industry to be able to comment on, and similarly there's other guidance out there that the MCA are issuing. But in the interim, until that point, the Maritime UK through SMI issue the Code of Practice, which you can see there, which is the UK MAS Regulatory Working Group, industry-based Code of Practice, of which James chairs and I chair subgroup A. So that is industry to industry best practice guidance and industry to regulator recommending best practice in the absence of anything else. So for those who aren't operating there, a really, really good read. And in order to assist and inform assurance, then increasingly we'll be using synthetic environments and digital twinning to provide that level of evidence base towards assurance. And Lloyd's Register and the National Physical Laboratory are doing a really big bit of work on putting together a maritime autonomy assurance testbed, so a framework capturing every facet of what maritime assurance in the autonomy area looks like, and then putting that together in effectively a UK package of assurance. So what does the future look like? And I hope you can see that diagram. I've got that from the Offshore Renewable Energy Catapult. A great diagram that basically articulates what a lot of pan-sector work is going towards, including in defense. So the nirvana is that you've got an agnostic control interface, pan-domain autonomy with a USV as Fugger operate with an ROV. So you might come up to wind turbine, the ROV goes down and does a pipeline inspection and inspects the groundworks, and then the UAV takes off and does all the blade inspection. But to get there, it requires a lot of work in the interfaces and the pan-domain control and the remote op center, the management of that. And I know the University of Newcastle master students approached me to say that we're doing some work in that area. I think you might be thinking, I've got the answers. I was hoping you have the answers, but we'll get there together. And I think the aim is to try and engage with everybody in industry and cohere and work out how we get to that stage. Certainly, there's lots of use cases for that. So how do we get there? I know it's a theme that lots of people touched on, but it's a really, really important theme. It's about collaboration, not competition. In fact, I learned a new word last week from, I think, a digital transformation area called co-opetition, which is a halfway house between symbiotic relationships between companies who can benefit from each other. So not compete, but not maybe halfway between the collaborate and compete. But it's a really good work. It's about fundamentally collaboration to make the UK go faster and put the UK on the world stage, and really is about innovation ecosystem. We hear that term a lot, but how do we knit together that? From our point of view, it's about knitting together the test and develop areas around the whole of the UK for marine robotics. So we exploit the diversity of thought, the diversity of environment, diversity of sort of expertise, where there's there's a lot of good sectors around the UK that are maybe geographically linked by expertise, and actually knit those together in the ecosystem is really powerful. And it generally does put the UK back on in the driving seat in the Maritime as a UK global footprint for a consultancy service. Come to the UK, we've got expertise across here, but we need places like SMI and brilliant people like yourselves to make that a reality. And the last slide, slightly off topic, but it's about the CEBOT group at Values are about diversity in the Maritime, and we help people and technology integrate. And interestingly, as we step forward and start to remote certain functions off the ship, into a remote ops center, then there ceases to be, in time, physical barriers to stop people getting in the Maritime. You no longer need the full medical certificate to climb up in the ladders. Actually, we need the brilliant workforce of the whole of the UK to help us revolutionize the Maritime. That's it from me. Thank you very much.